Hi, I want to talk to you about variables and data types. By the end of this lesson, I hope that each and every one of you will be able to differentiate between let and const, as well as recall 6 data types in JavaScript. All right, so let's start let and const. So when we talk about variables, variable can be a little bit of a misleading word. So variable, generally in programming, we kind of think of those as containers, stuff that we can store something in. For example, if I say let a equals 1, all right, now a is equivalent to 1. So if I log a, I see 1 show up in the thing. So I can use that in other code that I want. So I might say something like, let greeting mean I have taught this lesson times, and now I can log greeting, and it should just swap those out. Pretty straightforward. Hey, cool. So this kind of container idea, though, is actually a little bit more nuanced. So there's another way that we can save a variable called const. Now, if I swap this out like that, then it still works the exact same way. But if I try to change that, womp womp, it all falls apart. I change it back to let. I've taught the lesson 2 times. So we have let and const, 2 different ways that we can store data. And spoiler alert, I'm going to tell you right now, you should default to const. You should prevent this from happening. We want that error to show up. Now, before I move on, I want you to think why. Why on earth might I not want you to have the flexibility that let gives you, the ability to just reassign a variable whenever you want? I actually want you to think about this question. I'm going to give you a minute. Why might I not want you to be able to reassign a variable? Think about it. All right, time's up. Did you figure it out? The reason I might not want you to reassign a variable is that we add a lot of complexity to our code when the same variable can be more than one thing. Instead, if I did want to do something like this, then we could also, instead of reassigning it, we could just call it something else. We could call this this one 1. We could call that one 2, and then this becomes 2 or 1 or whatever. But instead of thinking of them as containers that we're storing stuff in, we can take it out, we can change what's in there. We can think about it more as a statement of fact. And if we have things that are a little bit more complex, like this, where we're combining different things, then we're making a statement of fact that this greeting is this string plus this number plus this string. So another reason that we might want to do that, it's kind of protecting us a little bit, is this idea of accidental reassignment. So let's say I have something like name is Coverly, and then I make a function that's something like set someone else's name. And this takes in a name as an argument, and I do something in here, and somewhere in the code I set, I'll call that new name, it doesn't shadow. So if I do that and then I run this function, and then I log name, that says Elise Coberly, not Kyle Coberly. So maybe this is exactly what I wanted to do. Maybe that was the whole point of the function. But imagine this is just some long file, has all kinds of other stuff in here. And I don't even realize that I'm setting this variable up here. That's an accidental reassignment. Now, if I have that as a const and I try to do it, it breaks. This is a good thing. I want this to happen. This is a warning that I did a reassignment. Now, if I want to loosen that up, I can change that to let, no problem. If I didn't want this to happen, I don't get a warning. It doesn't tell me that that happened and I didn't want it to. So I don't know that I should have tightened that up to const. And this is a broad idea in programming in general, is we want to start with the most restrictive thing possible and then gradually loosen that up. There's some okay reasons to reassign something. For example, if I'm writing a for loop, I can use let with this like iterator here and increment it every time. That's legit. Let's see, is it mad at me because oops, let I, come on Kyle, let I equal 1. And there we go, cool. So I get, count the numbers 1 through 9. So it's reassigning that I every time. That's a totally acceptable use. If I make it const, it probably breaks. It might still work. I don't think it will. Yep, there we go. So I have to use let there. But in general, start with const. We want to start with something that's restrictive. And to get to our objective, differentiating between let and const, big difference. Let can be reassigned. Const cannot be reassigned. We want to, by default, not reassign things. If we got a good reason to reassign something, no problem. But most of the time, you're better off making another variable. So much so that I would even say that anytime you see let in your code, pause for a sec. Is this a completely different thing? Make it a different variable. That easy. Okay, so our objective was differentiating between let and const. I want you to try to wrestle this into your own words. Like, all the things that I said, probably nodding along, going, yeah, cool, that sort of makes sense. I'm following along. If you're tracking from one thought to the next thought to the next thought, that's not the same thing as you knowing it. So I want you to try to write this in your own words. How would you differentiate between let and const? What things do they do that are the same? What things do they do that are different? And why? So I'm going to put 4 minutes on the clock. I want you to actually write down, try to wrestle this into language. It'll probably be harder than you might think. 4-minute timer starting right now. Differentiate between let and const. All right, time's up. So differentiating between let and const, both of them store values. Let can be reassigned, const cannot be reassigned. And the reason we care about this is that with let, we're kind of thinking of this as this like container. We take stuff out, we change stuff, we do whatever else. And that can cause accidental reassignment. We can do things that we didn't mean to do that way. So with const, we're making statements of fact. We're saying that this is this. It can't be anything else. It wasn't anything else before. It can't be anything else after. This makes our programs a little bit simpler and easier to understand. And if we do run across a situation where we really do want to do a reassignment, we get the error, and we go, oh, I can loosen this up a little bit. But we're not going to get that if we start with let. We won't know that we accidentally reassigned something. All right, that's our difference between let and const. All right, let's move on to our next objective. We're calling 6 different data types in JavaScript. So I'm going to put these in 3 different categories. There are actually 7 data types in JavaScript. There's only 6 that I care about you knowing right now. So this first group, I'm going to call bread and butter. These are the 3 data types that you just use day in, day out. They are strings, numbers, and booleans. String, pretty easy. Anything between quotes. So this is a string. It can be double quotes like this. It can also be, it can be double quotes like that. It can also be single quotes. One last one. It can also be backticks. They all do the exact same thing. Some difference, some nuance to it, is if I say this is Kyle's string, no problem. If I try to do that same thing in this one, falls apart because JavaScript doesn't know that I meant for this to be the last single quote and this to just be an apostrophe indicating that I'm plural. It just sees that and thinks I'm done with the string. So there's ways around that. You can use an escape character, which is the backslash. And then it's saying, no, I actually want to use like an apostrophe here. I'm not trying to end the string. That works okay. Similarly, if I want to use double quotes here, it doesn't know that I don't mean for that to be actual double quotes. So I'd have to escape those if I wanted to use them. The backticks are kind of nice because you can use either. Hey, cool, no errors, works just fine. Now there's one other cool thing that we can do with the backticks, and that is use templates. So if I did something like that, with the backticks, I can put just random JavaScript stuff in there and that'll work fine. So if I log that, it'll swap that out for the JavaScript variable. It's pretty cool. So that's like our first bread and butter data type. Another data type is numbers. This is exactly what it sounds like. So that's a number. It's not in quotes. It can be integers, it can be decimals, it can be big numbers, it can be small numbers. Now, in a lot of programming languages, there's tons of different number types. Only one in JavaScript. They're all numbers. Decimals, fractions, whatever. It's all just numbers in JavaScript. And so we can do numbery kinds of things with those too. I have another number is 3.1, and then I can say yet another number is some number plus another number. And if I log that, yet another number. Then if I log that, I get 6.1. So strings, numbers, pretty straightforward. Boolean, even more straightforward than that. Only two values, true, no quotes around it. Those are the only two possible values for Booleans. These are like data types that we use day in, day out for just regular kinds of programming tasks. So that's 3 of the 6 data types that I want you to remember. Another group I'm going to call empty data types. There's 2 of them in JavaScript, null and undefined. They both kind of work the same way. There's a slight difference between them. Undefined is something that has never been assigned a value. Null is intentionally something doesn't have a value. So what that looks like is, if I say this, let this is a variable. So if I stop there and log this is a variable, that's undefined. It has not been assigned a value yet. I could also have some value in there, and then that will print there. I could reassign that to null if I wanted to indicate that I am intentionally saying that there's nothing in here. In general, there aren't a whole lot of good reasons to use null, because if I want to like empty out this value, I can make it an empty string. That's also kind of indicating that I'm intentionally putting nothing in here, and I haven't actually changed the data type at all. It's still a string here, it's just a string with nothing in it. We can do this with like all 3 of these. So we can have an empty string, we can have 0, we can have false. All those kind of represent this concept of emptiness, but for a lot of reasons, JavaScript has a specific data type for that called null. Undefined is one you'll run across a lot. That's something that's never been assigned something. Anyway, those are 2 empty data types. And then the other one is in a class all its own, object. So the reason why this one is a big deal is that we can do kind of a lot of things with it. Ordinarily, it's just keys and values. So we open it up with curly braces, and we can put a key, and then this can be any of the other values. So this can be a string, it can be some number, it can be Boolean. And then we can access those by looking up the value with the key. It's like a dictionary. That's actually what they're called in Python, where we look up this word and its definition. Keys and values, we call them. So if I say some object dot some string, hey, there's the string. Some number. So we can use this to keep a bunch of things kind of grouped together. And the things, these can be any data type. They can also be more complex data types like functions and arrays and whatever else. And that's part of what makes objects interesting. Arrays, functions, promises, like all these other different kinds of things that you'll come across in JavaScript, they're actually under the hood just different kinds of objects. They're still just key value pairs underneath all of that. Like an object, for example, or an array. An array is actually like an object, except instead of having these like string keys, the keys are 0, 1, 2, 3, 4. Otherwise, it works very similarly. And so our basic data types in JavaScript, the ones you use day to day, got bread and butter. We have our empty data types, and we have our object data types. So why do we have to have different data types at all? The data types kind of define what sorts of things that we can do with them. So like, what happens if I add a string and a number? In some languages, actually, I'm going to pause there. What does happen if you try to add a string and a number? Think to yourself for a sec. So in a lot of languages, you can't do that at all. That'll throw an error. Now, in JavaScript, it tries to be friendly. It tries to sort of figure out what you mean. So like, for example, if I try to have some string and then add a number to it, it'll try to turn this number into a string and then just make that one big string. If I do it the other direction, nope, still works. So we actually get some kind of unexpected things working with different data types. Now, another like thing that is crucial to understanding what data types are all about is they define different things that we can do with them. So if I have some string here and I do .length, it'll tell me how many characters are in that. So there's 11 characters in that. If I try to do that with a number, that doesn't make any sense. It breaks. So same thing with null and undefined. They don't have lengths. So they can't actually perform that operation on them. Objects do have lengths. So this sort of defines what sorts of operations that we can do on those things. And then like also defines how they interoperate with each other. And that's one of the big differences between different types of objects like arrays and functions and stuff, is they have different types of operations that we can do on them, that we expect to be on those. All right, so I want you to be able to recall 6 different data types in JavaScript. We have our bread and butter ones, we have our empty ones, and we have objects. Oh, one other thing that I want to mention about objects, and this relates to our like reassignment conversation with let and const. So if I have some object that has some key and some value, so this is const, so I can't reassign some object to something else. If I do that, it explodes. What I can do is reassign that key. And if I look up some object dot some key now, I can reassign that, even though I used const up here. And there's a few different reasons for that, but we're protecting from reassignment of this object, not changing any of the values that are inside that object. We can still do that. So don't get tripped up by that. Also, one other thing that I want you to know about objects, and we'll talk about this in greater detail in another lesson, but objects are also special in that they're by reference. So what that means is, say I have a function and this takes in some number and changes some number to that. All right, so I'm going to have some other number up here. All right, so this is that like reassignment thing that we were talking about. If I call change the number with some other number, I reassigned it in there. If I log it, hey, it's 3. I changed it, except I didn't. If I log that, let me try that again. Oop, some number. Some other number. Okay, so that comes back as 3. Oops. Called change the number. All right, and so it's logging there. I can also, if I log what some other number is here, check it out. It's still 4. I changed it to 3 inside of there. It didn't actually change the original value. Our bread and butter values, these are primitive. What that means is that when we start using them in functions and passing around and stuff, we get copies of those. We can change those copies all we want. This works differently with objects, and only objects. The stuff inside of objects, we say that they're by reference. So if this instead is some object that has some number in it, all right, so now I have some object, and what this is going to do is change some object dot some number to 3, like that, and I pass in some object, and then I log some object. Check this out. They're the same. I changed both of them to 3. None of them are 4 anymore. When you pass objects around, it's working with the exact same thing every time. If you change it one place, you've changed it everywhere. That's a place that you are likely to get tripped up somewhere in your programming career. Bread and butter stuff. These are primitive values. We pass them into functions and stuff. We get copies every time. Strings, numbers, booleans. Have 2 empty values. You probably don't assign these things directly. Not a whole lot of good uses for null. Undefined, on the other hand, will run across. If you look up something that doesn't exist on an object, for example, you'll get undefined back. So that's one we got to be familiar with. Objects, keys and values. Most of our complicated data types are just different kinds of objects. And if our bread and butter variables, those are primitive, so we get copies of them in functions. In objects, we're always working with the same one. That's by reference. So goal was to recall 6 different data types in JS. Recall 6 different data types in JS. Can you do them? I'll give you 30 seconds. All right, How did you do? We're able to recall that we have strings, numbers, and booleans, bread and butter variables. Null and undefined are empty variables. And objects are like complex kind of variable. Keys and values, tons of different operations, by reference instead of by value. All right, those are the 6 types of data that you need to be familiar with. And again, a data type, this is defining the kinds of operations that we can do on a piece of data, how they can interact with other kinds of things. That's what data types are all about. And then we also talked about let and const, assignment, reassignment, why we might want to start with const instead of let. It's easier to loosen something up than it is to clamp down on it later. And that is an intro to variables and data types. Thank you very much. Cheers.